So we'll start the session in 2-3 minutes. We'll wait for others to join and then we can start. So let us start our discussion. So today we are going to see our logistic regression. So this is a new topic, logistic regression. This is another topic under supervised under unsupervised machine learning for us. So what do you mean by supervised machine learning? Supervised machine learning means when we know what is our target variable. When we know what is our target variable. When we are aware of what is our target variable, or we know what is our dependent variable, we can call such kind of problem as your supervised machine learning problem. So for example, the previous topics what we have discussed, simple linear regression and also multiple linear regression. Both these are examples of our supervised machine learning concepts. So in both our concepts, we were working with our target variable. So when you discuss the example of simple linear regression, our target variable was Sunday circulations. When you are working on your multiple linear regression problems, our target variable was miles per gallon. So whenever we are working with our target variable, it becomes a problem of supervised machine learning. So similarly, another example what we are going to study is today, logistic regression. This is another concept what we are going to discuss. So what kind of concepts or what kind of problems we can solve using our logistic regression? If you want to find out whether a person is going to get cancer in the future or not, if you want to find out whether a person is going to get diabetes in the future or not, if you want to find out whether it is going to rain tomorrow or not, if you want to find out whether a person has survived a crash or he has not survived a crash, all these kind of problems can be solved with the help of our logistic regression. So it is the first classification problem what we will be discussing. It is the first classification problem what we will be discussing. So it can classify your observations into two categories. Yes or no? Whether a person has survived the crash or he has not survived the crash. This is what you can understand. Whether the currency note is real or fake. So these kind of problems you can solve using our logistic regression. Mostly in our use cases, we are going to limit our discussion to a binary classification problem. We are going to limit our discussion to binary classification problem, where we'll be working with only two classes, or we'll be working with only two outcomes or two categories for us. That is going to be the area of focus for us. We'll try to solve a binary classification problem using the concept of logistic regression. Now, logistic regression. It is a classification algorithm for us, where our response variable or target variable is categorical for us. Our response variable or target variable is categorical. And usually we'll be working with a binary response variable. What do you mean by binary response variable? A target variable which is going to have only two categories, 0 or 1, or yes and no. We'll be working with only a two-class problem for us, a binary response variable problem. So rather than predicting the two values, in our logistic regression, we will try to model the probabilities that my two categories can take. So we are interested in modeling the probability related to our two categories, 0 and 1, or yes or no. What is the probability that it is going to rain tomorrow or not? So there is a 99% chance of rain. There is 1% chance of not raining tomorrow. So this is the concept. We are interested to make our prediction, but we will be predicting our probability values. What is the probability that the person is going to get diabetes in the future? Yes, there is a 80% chance. No, he is not going to get diabetes. There is a 20% chance. So we will be predicting our probabilities. That is an important concept, what we have to understand. So the idea of logistic regression is to find a relationship between our features and the probability of particular outcome. To find out a relationship between our independent variables and our probability values related to our outcomes, yes and no. This is what we are interested in. We have to find out a relationship between independent variables and probabilities of two outcomes, yes and no for us. That is the idea, what you're supposed to have. So let us take a look at one example. What is that example is? We have to find out whether that person is going to get cancer in the future or not. So if that person is going to get cancer, you are going to assign a value of 1. If that person is not getting cancer, you are going to assign a value of 0. That is what you are doing here. Now, based on all our independent variables, what are our independent variables? Age, sex, smoking, diet, family's medical history. Using all these features, we have to find out whether that person is going to get cancer in the future or not. Yes or no. So this can be one of the problems which you can solve with the help of our logistic regression concept. What is another use case or problem that you can solve with the help of logistic regression? For example, if you want to study the financial health of a company, if you want to understand whether the company is going to file for bankruptcy, or if the company is not going to file for bankruptcy, you can solve this kind of problem also with the help of our logistic regression concept. So if the company is going to file for bankruptcy, you can assign a value of 0. If the company is not going to file for bankruptcy, you can assign a value. We can do this. So what is it we have to find out now? We have to use our different financial indicators, such as study the company's profit and loss statement, study the company's balance sheet, study the company's cash flow statement. And using our financial indicators, we are supposed to make a prediction whether the company is going to file for bankruptcy or the company is not going to file for bankruptcy. That is what is our objective. Okay, that is what we have to find out. Okay. Yes, slowly we are going to discuss that topic. Okay, can you all hear my voice? Is my voice audible? Or it is not audible? What is the status?
Yes, Varun, it's audible.
Without any difficulty, without any breaks, can you hear my voice? Okay, 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 fine. Thank you. Thank you very much. So let us continue our discussion. Our job is to find out financial indicators by studying profit and loss statement of the company, by studying the balance sheet of a company, by studying the cash flow of a company, and then you have to make your prediction whether the company is going to file for bankruptcy or not. So for solving these kind of problems, our logistic regression concept is going to help us. Our logistic regression concept is going to help us do this. So how we are going to discuss in few minutes. With the help of Python functions, you can do this. Now, what are the common questions that you have? Common questions that we may have is, why do I have to study this topic of logistic regression? What is the reason for studying this topic? Why can't I solve these problems using the concept of linear regression and interpret the outcome? Can I use my linear regression to solve these problems? That is the first question what we would like to answer. What is the second question we would like to answer? Since the response variable or target variable is qualitative in nature, it is categorical in nature, what is that we are going to actually predict when we are solving these kind of problems? Since our target variable is categorical in nature, what is that we are trying to predict? So these two questions we have to answer. So before we answer these two questions, okay, we'll try to understand our case study, what we are going to do. So the case study, what we are going to discuss is, we are going to consider one insurance problem. So there are 1340 observations or patients who are willing to claim for their insurance payments from a single state in USA. And this survey was conducted by Insurance Research Council. So 1340 observations we have in our data set who are willing to claim for their insurance payments from a single state in USA. And this survey or data has been collected by Insurance Research Council first. What is the purpose of this survey? The purpose of this survey is to understand the characteristics of claimants, to understand the characteristics of people who are claiming for their insurance payment, who wish to be represented by a lawyer when they are settling their insurance claim? What is the question? We have to understand the characteristics of claimants who wish to be represented by a lawyer when they are trying to settle their claim. That is the problem. So we want to understand how many or what are the characteristics of customers who wish to be represented by a lawyer when they are trying to settle their insurance claims. That is the problem. Why are we interested in finding out? Because the profits of an insurance firm is found to be dependent whether the claimant is going to consult a lawyer or not. So if that claimant is going to hire a lawyer or consult a lawyer, it can impact the profits of an insurance company. So insurance company wants to understand who are those customers, who are those claimants who are going to consult a lawyer. So what is the overall objective of the problem? The insurance company is interested in finding out the probability of claimants who wish to be represented by an attorney or lawyer. So we have to find out what is the probability that the customer or claimant is going to consult a lawyer. What is the probability that the customer or claimant is going to consult a lawyer? Or what is the probability that the customer or claimant is not going to consult a lawyer? That is what we have to understand. So that is the problem objective for us. We have to find out whether that customer or claimant is going to consult a lawyer or not. So depending upon the demographic characteristics of claimants who consult a lawyer, depending upon the characteristics of people who are going to consult a lawyer, the insurance company is going to design different policy instruments for different target groups. So if the insurance company can understand who are those customers who are going to consult a lawyer, then the insurance company is going to develop new policy instruments which are going to help these kind of customers or claimants. That is the idea. That is the objective. Why the insurance company wants to understand who are those customers who are going to consult a lawyer when they are trying to settle their insurance claim. This is the problem all about. So after you have read the problem statement, what is the next course of action? You have to focus on the data set. What is the data that we are going to work with? The data that we are going to work with is called as claimant data set. It is called as claimant data set. This is what we are going to use. So in this, what is our target variable? Our target variable or dependent variable is called as attorney first. It is called as attorney. So if the person is going to consult the attorney, you are assigning a value of 0. If the person is not going to consult the attorney, you are assigning a value. So all this information will be given in your problem statement. You have to make sure that you have all this information. Description about your target variable and also description about your independent variable is important. So this is our target variable. Now what are our independent variables? Our independent variables are claimant age, number of years. Second independent variable is claimant sex or gender. If that person is male, you can assign a value of 0. If that person is female, you can assign a value of 1. This is what you are going to do. If that person is 0, you can assign a value of male. If that person is female, you can assign a value of. What is the third independent variable? Seat belt. Whether if that person is wearing a seat belt, you can assign a value of 0. If that person is not wearing a seat belt, you can assign a value. This is our third independent variable, seat belt. Our fourth independent variable is claimant insurance. You can assign a value of 0 if that person is having insurance. You can assign a value of 1 if that person is not having insurance. You can do this. Now, what is our last independent variable? Economic loss. What is the loss incurred during the accident? That is called as economic loss first. So using all my independent variables, I can write down my equation like this. Where have you seen this equation? It is very similar equation what you have seen in case of your multiple linear regression. This is our target variable y. These are all my independent variables. And beta naught, beta 1 are called as my coefficients. So most of my data, if you see, it is in the form of ones and zeros for us. Most of your independent variables and your target variable information is in the form of ones and zeros. So what is it we have done? We have converted our categorical data. We have converted our information present in our categories into ones and zeros for us. This is what we have done. We have converted the information into ones and zeros. So this conversion of categorical data into numbers, ones and zero is called as dummy variable concept. Creation of your data in the form of ones and zeros from different categories that you have in your data set is called as creating your dummy variables. So that is why you have replaced all your variables with dummy values. What are those dummy values? Ones and zeros. Why are we doing this? Because it is going to help us in processing our data. So this is how you process your categorical information using the concept of dummy variables, converting your categorical data into ones and zeros first. So all these concepts you have to remember, and you have to take down notes, and you have to learn these concepts. That is very important. So now we have our data set ready. Now, what is the question we would like to answer? Can I apply this multiple linear regression concept in solving these kind of problems? That is the question. Why should I learn a new topic called a logistic regression? Can I simply use the topic of multiple linear regression and solve these kind of problems? So what is the answer to that question? Let us try to find out. So if I give you a question, whether it is going to rain tomorrow or not. So we cannot say with 100% accuracy that it is going to rain tomorrow or not. What is it you are going to do? You are going to say 97% there is a chance of rain tomorrow. And there is a 3% chance that it is not going to rain tomorrow. So we have to deal with probabilities here. So we cannot say with 100% guarantee or surety that the person is going to consult a lawyer. So we have to work with our probability values. So the only sensible thing for us to do is to predict the probability that the claimant is going to consult a lawyer. So the only sensible or logical thing for us to do is predict the probability values. This is what we are supposed to predict our probability values. Now, so how will this modify our equation? Now, using all our explanatory variables, using all our independent variables or predictors or regressors, we have to make sure that we predict our probability values. So now I am slightly modifying my target variable. Instead of only writing y, I am writing it is an expectation. Expectation means probability. So it has become now a problem where we have to work with our probability concepts. So using all our independent variables, you are supposed to predict what is the probability of your outcome. You have to predict what is the probability of output. That is the slight modification what we have done to our equation. This is a slight modification what we have done to our equation. Now, let us try to use this multiple linear regression and let us try to predict the probability values. What is the result we are going to get? Let us try to understand. So we are working with the linear regression output, and these are all my independent variables, and these are my p-values for my independent variables. And now I am selecting some random observations. I want to understand what kind of predictions my model has made for random observations present in my data set. So I'm taking some 8 observations. I'm taking 1, 2, 3, 4, 5, 6, 7. 7 observations I'm taking. And then these are the actual values for my 7 observations. 0, 0, 0, 0, 0, 1, 1. What is my predicted value from my model for these 7 observations? What is that I'm getting? I'm getting a value 0.48. I'm getting a value 0.545. I'm getting a value minus 0.15. I'm getting a value 0.46. Like this, I'm getting some predicted values from my multiple linear regression model that I've used. Now, what is the challenge? What is the difficulty we are having with these values? I'm trying to predict my probabilities, but you see, my probability can never be negative. My probability value can never be negative for us. So what is happening? Therefore, we are not supposed to work with our multiple linear regression model. Why? Because it is predicting negative values for our probability, and probability can never be negative for us. That is the first challenge what you are going to face. Some predicted values are negative for us. What is the second challenge you are facing? Sometimes not all the predicted values are going to lie between 0 and 1. Sometimes whatever predictions you are making, they may not lie in the interval of 0 to 1 for us. That is a challenge what you are going to face. So therefore, what is happening? Because of these two reasons, because your probability cannot be negative, your probability cannot be less than 0, or it cannot be more than 1 for us. So therefore, it is not advisable for us to work with our multiple linear regression model. So finally, we have decided that this model is not going to work. Your linear predictive model is not going to work for us. That is the conclusion, what you are supposed to make from our analysis. So visually, if you want to understand, how can you understand that these are your set of observations in your data set, and you are completely fitting the wrong equation. You are trying to develop a linear predictive model which is not at all capturing the information present in your data, which is not able to understand the nature of your observation present in your data set. Therefore, your multiple linear regression model is incorrect model for solving these kind of problems. These kind of problems, it is incorrect for us. So this is what we have to remember. This is what we have to understand. Now, then what is the alternate solution that we have? If we cannot work with our multiple linear regression model, then what is the alternate solution? We have to take the help of what is called as logistic function for us. We have to take the help of this function. So whatever output you are going to get from your multiple linear regression model, you are simply going to substitute this value of y in our logistic function. What is that you are going to do? You are going to substitute the value of y in our logistic function. That is what you are going to do. So what is our logistic function? Our logistic function can be written as 1 by 1 plus e power minus 1. This is what I can do. So I'm going to write my logistic function in this manner. 1 by 1 plus e power minus 5. So whatever output I'm going to get from my equation, I'm going to substitute here in place of 5. In my logistic function, I'm going to substitute. What is this logistic function going to do? It is going to take any real valued number and it is going to transform that value into any number between 0 and 1. It is going to transform that value into any number between 0 and 1. So we can convert whatever output we are going to get from our equation into our probability values, into a value between 0 and 1 first. That is the purpose of using the logistic function 1 by 1 plus e power minus 5 first. So this logistic function, you can also call it as a sigmoid function. You can also call it as your sigmoid curve. So what is the formula for probability? 1 by 1 plus e power minus 5. So whatever value you are going to get from your multiple linear regression, simply substitute it in your logistic function. And your logistic function is going to convert that value into a probability value, which is going to lie between 0 and 1 for us. That is what you're supposed to do. So I'm slightly going to modify my logistic function equation. 1 by 1 plus e power minus 5. I can write this as 1 by 1 plus 1 by e power y. Take the LCM. E power y is going to go on top. You will be getting this term. E power y by e power y plus 1. This is the probability. So remember this formula. This is the formula for you to calculate your probability values. E power y by e power y plus 1. That is what you are going to do. Now, how can you represent your logistic function diagrammatically or visually? How is it going to look like? It is going to look like this S-shaped curve. Your logistic function is going to look like this S-shaped curve. This is also called as your sigmoid curve. This is also called as your sigmoid curve for us. Sigmoid. So remember this. You can represent your logistic function using your S-shaped curve, or you can call it as your sigmoid curve. So whatever input you are going to supply, it is going to transform the input into a value between 0 and 1. It is going to transform that value into a number between 0 and 1 for us. So conveniently, we can convert all your inputs into probability values for us. So this concept, again, we are going to discuss when we talk about your neural networks topic. There, your logistic function can be called as an activation function. So there we are going to see. There I'm going to ask you one question. What are the different activation functions that we have discussed so far? So what is the answer? The answer is logistic function. It can be used as one of your activation functions for your neural networks model. So this is our logistic function, sigmoid curve. So whatever inputs, any real number can be supplied as your input, and it is going to map that value into a value between 0 and 1 first. 0 and 1. This is your sigmoid. This is what you are going to do. Now, what is the next thing that we have to understand? What is the equation of your logistic regression model? What is the equation of logistic regression model? So how can we write down? What is the equation? So for writing down the logistic equation, logistic regression equation, I'm going to introduce one term. What is the term? A natural logarithm of p by 1 minus p. So there is new this term, what I am introducing. So first follow what I am doing here, and then you will understand how I am doing this, and also then eventually you will understand why I have introduced this term, natural logarithm of p by 1 minus p. So for solving any kind of problem, you have to use this approach. First what, then how, then eventually you will understand why. You should never start with why. You will not progress. This is not the correct way of solving any problem. You have to start from what, how, and why. So what is that I'm doing here? I'm trying to introduce one new term which is called as natural logarithm of p by 1 minus p. Now what I'm going to do is, I'm going to equate it to y. Log of p by 1 minus p, I'm going to equate it to y. Now observe what is the result we are going to get. So p by 1 minus p can be written as e power y for us. Take the reciprocal. 1 minus p by p is equal to 1 by e power y. 1 by p minus 1 is equal to 1 by e power y. 1 by p is equal to 1 by e power y plus 1. 1 by p is equal to 1 plus e power y by e power y. So what is e power y? Or what is p? P is equal to e power y by 1 plus e power y. Where have you seen this? Just now we have seen this in our logistic function equation. Just now we have seen 2 minutes back. This was the equation for our logistic function. So this new term, when I'm equating it to y, it is going to become equal to our logistic function equation. So this is a small construction that I'm doing here. I'm introducing this new term so that it is equivalent to our logistic function equation. Now, how can I write down my final equation for my logistic regression model? What will be my final equation? Natural logarithm of p by 1 minus p is equal to y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 and so on, beta n xn plus error. This is what is going to be my final equation. The log of p by 1 minus p is equal to y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus so on, beta n xn plus error. This is my final equation for my logistic regression. Final equation. So this is what we have to understand. So the same information you are going to see in our slides. The same information you are going to see in our slides. So this is our initial linear predictive model or multiple linear regression equation. This is what we have. And now this entire y term you can substitute in your logistic function 1 by 1 plus e power minus y. So in place of y, you can substitute your linear predictive model, what you have developed. And now we have called it as y. They are calling it as z. There is no difference. 1 by 1 plus e power minus z. This I can write it as 1 by 1 plus 1 by e power z. So e power z by 1 plus e power z. So it is very similar to e power y by 1 plus e power y. So this is what they are also getting. This is what we have also got, where y is nothing but our entire linear predictive model equation. So same thing even we have also got. Now they are also introducing this new term, log of p by 1 minus p, because this is going to resemble that of your logistic function. And this is how you can write your entire equation for your logistic regression model. That is what you get. So what is this equation can be called as? You can call this as your logic model, or you can call it as your logistic regression. You can call it as your logic model, or you can call it as your logistic regression first. That is what you are going to do. Now, what is this term that I've introduced? Log of p by 1 minus p. Let us try to understand what is this p by 1 minus t term. First, let us try to understand what is this term. P is nothing but it is the probability that the claimant is not going to be represented by attorney, or claimant is not going to consult an attorney. So we are assuming that P is the probability that the claimant is not going to consult an attorney first. What is 1 minus P? It is the probability that claimant is going to consult an attorney. So P is, it is the probability that claimant is not going to consult an attorney. 1 minus P is, it is the probability that claimant is going to consult an attorney first. So this P by 1 minus P is the ratio of probability that claimant is not going to consult an attorney to probability that he is going to consult an attorney first, consult a lawyer first. So this ratio of probabilities is called as odds ratio first. What is this called as? It is called as odds ratio. This ratio of probabilities. So remember that P by 1 minus P is called as odds ratio for us. Now, what do you mean by odds ratio? If I say P by 1 minus P is 2, if my odds ratio value is 2, what is the meaning of this? What is the value of P? P is 0.66. 1 minus P is 0.33. So 0.66 by 0.33 will give you 2. So this is my odds ratio. If I say my odds ratio is 4, what is the meaning of this? P value is 0.8. 1 minus P is 0.2. So 0.8 by 0.2 is 4. Now what is happening? Let us try to understand. If my odds ratio is increasing from 2 to 4, what is happening? The probability that the claimant is not going to consult a lawyer is increasing from 0.66 to 0.8. The probability that the claimant is not going to consult a lawyer is increasing for us. Then what can you say? It is good for the company. So there is a very high chance that the person is not going to consult a lawyer. It is good for the company first, for the insurance firm. So when your odds ratio is increasing from 2 to 4, the probability that the claimant is not going to consult the lawyer is going to increase from 0.66 to 0.2. What will happen if the odds ratio is decreasing from 4 to 2? What is that you can say? We can say that the probability that the claimant is going to consult a lawyer is increasing from 0.2 to 0.36. Probability that the claimant is going to consult a lawyer is increasing from 0.2 to 0.36. So there is a very high chance that the claimant is going to consult a lawyer. So it is not good for the company. It is not good for our company. So that is how you can understand the odds ratio concept, P by 1 minus P. Now, odds ratio will also help us in interpreting the relationship between our independent variables and target variables. Odds ratio is going to help us in interpreting the relationship between our target variable and our independent variables. So now the question is, how is it going to help us? How is it going to help us in interpreting the relationship between your target variable and independent variables for us? For example, let us consider that you have built your logistic regression model. Okay, this is what you have done. This is my target variable followed by all my independent variables. And these are the results what I have got. So in my results, what is that you can understand? You have all your coefficient values for your independent variables. These are all your coefficient values, beta naught, beta 1, beta 2, beta 3, beta 4, beta 5. And accordingly, you have your p values. So if your p value for your independent variable is less than 0.05, then what can we say? That variable is significant for us. It is important. If your p value for your independent variable is less than 0.0, you would have seen this in your multiple linear regression and simple linear regression concepts. If your p value is greater than 0.05, then it is not a significant variable for us. It is not an important variable what you have to consider in your equation. Therefore, you can ignore those variables. You can do that. So now if you see, my claimant 6 is having a p value of less than 0.05. So it is a significant variable for us. Claimant 6. Then my claimant insurance, if you see, that is also having a p value of less than 0.05. So claimant insurance is also a significant variable for us. Then what about loss? Economic loss is also having a probability value of less than 0.05. That is also a significant variable for us. That is also a significant variable for us. Now, after identifying our significant variables, what is that we are going to do? Let us write down our logistic regression equation. And this is my logistic regression equation. Now, I'm going to consider one term, loss, economic loss. So this is my loss variable. What is the coefficient which is associated with loss? It is minus 0.38 into economic loss for us. So now observe what I'm going to do here. If I increase my loss value, if my loss value increases, then what is going to happen? This entire term is going to become more negative for us. it is going to become more negative if my loss value increases. Then what will happen to the left hand side? Automatically, this left hand side value will also become very, very small for us. So if my left hand side value is also becoming very, very small for us, what can you say about the denominator? Your denominator value is increasing for us. Only then it can become very, very small for us, your left hand side. So what is happening? If my loss is increasing, then 1 minus P is also increasing for us. What can you say about this? So if your economic loss increases, then the probability of consulting a lawyer will also increase. Then there is a very high chance that the customer or the claimant is going to consult a lawyer if he's having higher loss. If he has incurred higher damage during the accident, then there is a very high chance that he's going to consult a lawyer. So as your loss is increasing, 1 minus P probability is also going to increase. What about P? Probability is going to decrease. What is the meaning of this? The probability of not consulting a lawyer is going to decrease for us. So as my economic loss is increasing, the probability of not hiring a lawyer is going to decrease, is going to reduce for us. Whereas the probability of consulting a lawyer is going to increase. So what is that we are doing? We are trying to interpret the relationship between our independent variables and our odds ratio. That is what we are doing. That is how the odds ratio can help us. Understanding the relationship between our independent variables and dependent variables. That is the logic. That is the idea. So as your economic loss is going to increase, then the probability of consulting a lawyer will also going to increase. 1 minus P value is going to increase and P value is going to decrease. So the same thing we can understand from our slides. So as your loss is increasing, the log odds ratio in favor of claimant not being represented by attorney is going to decrease. P value is going to decrease. And then the probability that the claimant is going to be consulting a lawyer is going to increase for us. 1 minus P value is going to increase. So that is how we can understand the concept of odds ratio for us. That is the logic. So your significant variables are claimant sex, claimant insurance, and loss. These are our significant variables. So that is how you are going to interpret your odds ratio from your logistic regression model output. That is the idea. Now, after we have developed our model, what is the next step? After we have built our model, what is the next step that we are going to do? We have to make our predictions. After predictions, what is the next step? We have to evaluate the performance of our model. So what are the different ways in which we are going to evaluate the performance of our model? We'll have to understand. What are the different methods which are available for us? Confusion matrix. And then under confusion matrix, we'll be discussing topics like sensitivity, specificity, precision, recall. So recall is nothing but sensitivity. We are going to see that. F1 score, all these topics we are going to discuss. And also there is another method by which you can find out the accuracy for your model. It is called as ROC curve. Full form is receiver operating characteristics. This is the full form. Full form is receiver operating characteristics. That is the idea what we are supposed to do. So both these methods we are going to see. Confusion matrix and ROC curve we are going to discuss after a break. So we are going to take a break here for 10 minutes. We are going to come back and we are going to continue our discussion on confusion matrix and ROC curve. So let us continue our discussion. So we have to start off with confusion matrix. Confusion matrix is nothing but you have discussed the same concept in hypothesis testing when we were discussing the topic of errors. There you have seen a similar matrix like this. So it is the same concept what we are going to use here. What is this confusion matrix all about is you have your row names as your predicted values. You have your column names as your actual values. So we are trying to compare your predictions with your actual values. And then we can find out what is the accuracy for our logistic regression model. We can find out what is the accuracy. Now, let us try to first assume my positive class is 1 and my negative class is 0. So this is the assumption what we are going to make. 1 is my positive class, 0 is my negative class for us. Now, you can see it is a 2 cross 2 matrix for us. You have 2 rows and you have 2 columns. And we have to understand what do you mean by A, B, C, and D. What are these values? So there are 4 situations for us. Let us try to understand all the 4 situations. The first situation is when your predicted value is 1 and your actual value is also 1. Then you can call those predictions as your true positive values. What is that you are going to call? You are going to call those predictions as true positive values. This is TP, true positive. What is the second situation? When your predicted value is 0 and your actual value is also 0. What is that you are going to call those predictions as? You are going to call them as true negative values. They are your true negative values. So you have true positive values, you have true negative values. This is what we can call. Now, there is also a third situation for us. What is the third situation? When your predicted value is 1 and your actual value is 0, what is it you are going to call? You are going to call those predictions as false positive values, FP. They are your false positive values. You are predicting them as positive, but it is false. It is actually 0 for us. You can call them as false positive false. 4. What is the fourth situation? Your predicted value is 0, but your actual value is 1. What is that you can call those predictions as? False negative false. False negative. That means your prediction is negative, but it is actually false. Actual value is positive false. So instead of predicting as 1, we are predicting as a 0. These kind of predictions are called as false negative predictions for us or false negative values. So false positive you can also call as type 1 error for us. That is what we have discussed there. And false negative you can also call it as type 2 error. So whatever concepts you are going to discuss in basic stats, all of them we are going to apply in our machine learning models. So now I can replace all these values. A, B, C, D with my true positive, true negative, false positive, false negative values. These are my predictions. These are my actual values. Now, how can you find out the accuracy from your confusion matrix? What is the formula? The formula to find out your accuracy is TP plus TN divided by TP plus TN plus FP plus F. This is the formula. So what is the accuracy for this confusion matrix? 40 plus 40 divided by 40 plus 40 plus 10 plus 10. What is the answer? 80 by 100. It is 80% is your model's accuracy. So write down this formula: TP plus TN by TP plus TN plus FP plus FN. That is the formula for accuracy. What is the formula for error? 1 minus accuracy for us. What is 1 minus 80%? It is 20%. That is the error for your model. Or what is the formula for error? If you want to manually calculate, it is FP plus FN divided by TP plus TN plus FP plus FN. This is the formula for error. FP plus FN by TP plus TN plus FP plus FN. That is the formula. So this is how you can find out your accuracy and error from your confusion matrix. So this we are going to create in our logistic regression model in Python. We are going to do this. Now, what do you mean by this confusion matrix? Your model has correctly predicted 1 as 1. How many times? 40 times. Your model has correctly predicted 0 as 0. How many times? 40 times. Your model has wrongly predicted 0 as 1. How many times? 10 times. Your model has wrongly predicted 1 as 0. How many times? 10 times. So that is how you can understand the elements present in your confusion matrix. That is what we are going to do. Now, we have to understand some terms. What are those terms? Sensitivity. What is the formula for sensitivity? A by A plus C. What is A? TP divided by TP plus FN. This is the formula for sensitivity. What is your sensitivity trying to tell us? How accurate is your model in predicting the value of 1? How accurate is your model in predicting the value of your positive class? That is what your sensitivity is trying to tell us. Out of your total number of positive observations that you have in your data set, how many of them is your model correctly able to predict as positive? So it is the accuracy with respect to your positive class. How accurate is your model in predicting your positive class? You are going to call that as sensitivity for us. So higher the sensitivity value, higher is going to be your accuracy for your model for your positive class. So more the sensitivity, higher the sensitivity, the better is our logistic regression model that we have developed. So what is the sensitivity? What is the formula? 40 divided by 40 plus 10. 40 by 50, this is 80%. 80% is the accuracy with respect to your positive class. You can find out from your confusion matrix. 40 by 40 plus 10. Now, higher the sensitivity, the better is our model. That is what we can understand. What about specificity? What is the formula? It is D by B plus D. What is D? D is true negative divided by true negative plus false positive. So it is the accuracy with respect to your negative class or zero class. How accurate is your model in predicting your negative class or zero category? So out of your total number of negative observations in your data set, how many of your observations are being correctly predicted as negative by your model? That is called as specificity for us. So what is the specificity formula? Tn by Tn plus Fp, true negative by true negative plus false positive. So 40 by 40 plus 10. 40 by 50 is 80%. That is the specificity of your logistic regression model. It is 80% accurate when it comes to predicting your negative class observations. It is 80% accurate. So higher the specificity, the better it is for us. Higher the sensitivity, the better is our model. Higher the specificity, the better is our model. So this is what we are supposed to understand from sensitivity and specificity. So sensitivity is also called as recall. Sensitivity is also called as recall or true positive rate. It is called as recall or true positive rate for us, sensitivity. What is specificity? Specificity is also called as true negative rate for us. So sensitivity is called as true positive rate or recall. Specificity is called as true negative rate. So remember these terms. Remember the formulas. They are important for us. So no need of any manual calculations. In Python, when you are doing for creating your confusion matrix, you can use a ready-made function called confusion_matrix. And for finding out your values for sensitivity and specificity, you can make use of classification_report functions. When you use this, automatically you will be in a position to find out what is the sensitivity, what is the specificity for our observations. You can do that. You can find out what is the sensitivity and specificity for our logistic regression model. Now, sensitivity is called as recall or true positive rate for us. What is the formula? TP by TP plus Fn. TP by TP plus Fn. That is sensitivity for us. It is also called as recall or true positive rate. So sensitivity is the conditional probability that the predicted class is positive, given that the actual class is also positive. Given that the actual class is positive for us, how many of your observations your model is correctly able to predict as positive for us? That is called as sensitivity. What is specificity? It is called as true negative rate for us. So what is the formula? Tn by Tn plus F. So given that the actual class is negative, how many observations your model is correctly able to predict as negative? That is called as specificity for us. So out of the total number of actual negative observations you have, how many of them your model is correctly able to predict as negative observations? That is called as specificity for us. So higher the specificity, higher the sensitivity, the better is our model. Better is our model. This is what we are supposed to understand. What is precision? Precision, what is the formula? TP by TP plus FP. So out of the total positive predictions that you have made, how many of them are actually correct predictions? Out of the total predictions what you have made for your positive class, how many of them are actually correct? That is called as precision for us. So given that the prediction by the model is positive for us, how many of them are actually your positive predictions? That is called as precision. So how can you find out your precision? From the confusion matrix, 40 upon 40 plus 10. 40 upon 40 plus 10, it is 40 by 50. It is 80%. That is the precision for our model. Higher the precision, the better it is. Higher the precision, the better it is for us. That is what we have to understand. So precision, you can define it like that. What about F1 score? F1 score is nothing but it is the harmonic mean between our precision and recall. It is the harmonic mean between precision and recall for us. So what is the harmonic mean? What is the formula? 1 by precision plus 1 by recall. So this is the formula for our F1 score. So if you take the LCM, will go to the top and you will be left with precision plus recall. Take the LCM is going to go to the top, and then in the denominator you are going to have precision plus recall. So this is the formula for F1 score. So what is the range of F1 score? F1 score is going to lie between 0 and 1 for us. Imagine the recall value for your model is 0. Then your F1 score is going to become 0 for us. If your recall value is 0. If your recall and precision value is 1. Then what is going to happen? 2 into 1 into 1 plus 1 plus 1. This value is 1. So F1 score value is going to lie between 0 and 1 for us. These are the limits for your F1 score. These are the limits. So higher the F1 score for our model, higher the F1 score, the better it is for our model, the better it is. So higher the sensitivity, higher the specificity, higher the precision, higher the F1 score, the better it is for our model. That is what we have to understand. So all these terms you can calculate using our classification underscore report function in Python, and it is going to compute all these values for us. That is what we are going to see in few minutes. So this is the first method of finding out your accuracy using your confusion matrix. What is the next method? ROC curve. This is the next method what we are going to use for finding out the accuracy for our model. So ROC curve is going to measure, or it is going to distinguish between a false alarm and a true signal for us. It is going to distinguish between a false alarm and a true signal. So it is going to distinguish between your true positive rate values and your false positive rate values. So on your x-axis, you have your false positive rate observations or values. On your y-axis, you have your true positive rate values. So true positive rate is also called as sensitivity or recall for us. False positive rate is also called as, you can write your false positive rate as 1 minus true negative rate. And true negative rate is specificity. So on your x-axis, you have 1 minus specificity. On your y-axis, you have your sensitivity or recall. On your x-axis, you have 1 minus specificity. And you are going to get your ROC curve. So this is my ROC curve. So what is that you can understand from your ROC curve? What is the concept that it is going to use? ROC curve uses a concept called as area under the curve. It uses one concept called as area under the curve or AUC. So imagine this box is representing 100% of your area. This box is representing 100% of your area. Now, if I get my ROC curve for my logistic regression model as this black color dashed line, what does this mean? If I get my ROC curve as this black color dashed line, it means that the area under the curve is 50%. This is 50% area. This is 50% area. Just ignore that you don't have this red color line for it. You don't have this red color curve. You just have this black color dashed line. So area under this curve is 50%. So what can you understand? If the area under the curve is 50%, accuracy for my model is 50%. When the accuracy for my model is 50%, my model is not having any skill. It is not having any skill. It is not able to distinguish between my 1 and 0 category. It is getting confused. It is not able to clearly distinguish between my positive class observation and my negative class observation. It is a model which is getting confused. So that is what you are supposed to understand when the area under the curve is 50% first. Now, suppose when you build your logistic regression model, and for that logistic regression model, if you get a ROC curve like this, which is exactly on the border for us, then what is the area under this curve? Imagine that you don't have this black color dashed line and you don't have this red color curve. What is the area under this entire box? It is 100%. So that means the model what you have developed is having 100% accuracy. It is a perfect classifier for us. It is a perfect classifier. It is correctly able to distinguish between 1 and 0 for us. That is the understanding what you are supposed to have. It is correctly able to identify between a true positive value and a false positive value. So it is a perfect classifier for us. Now, suppose if you get your ROC curve for your logistic regression model like this red color curve, what we are getting. What is the area under this curve? Roughly between 100 and 50%. I'm assuming 70%. So what is that you can conclude? Your model is having accuracy of 70%. So your model is having some skill which is capable of differentiating between your 1 and 0 category. So it is able to identify what is 1 and what is 0 with an accuracy of 70%. So that is what we are supposed to understand from your concept of ROC curve. Receiver operating characteristics. It uses the concept of area under the curve. That is the logic. You can plot it between your true positive rate values and false positive rate values. So ready-made functions are there in Python for doing all these things. And we are going to see that. So let us go to our Jupyter notebooks and let us try to see how can you solve these concepts. How can you program these concepts? So I will be sharing this model with you anyways. I will be sharing with you once I get the drive access and all. I'll be sharing the data set. I'll be sharing the code. I'll be sharing the presentation, what we have used. All these things will be shared across. So there is all the information what you require to practice this logistic regression concept. So I think attendance link has to be circulated. So please do so. Himavant.
Yes, 1 second.
So yes, this is our program. So import our basic libraries like we always do. Import our pandas, numpy, seaborn library, matplotlib.pyplot. All these regular libraries imported. And then from sklearn.linear_model, import your logistic regression. So we are going to start using our sklearn models, which are going to have all our machine learning functions. So logistic regression. You can also use your sklearn library for working out your linear regression problem also you can do. So this is the first time what we are seeing your logistic regression function. From sklearn import metrics for creating your confusion matrix. From sklearn.metrics import your classification_report for finding out your sensitivity, accuracy, all those things. F1 score. Now read your file. What is our data set? Claimants.csv. This is the data set. So you have different columns in your data set. You have case number column, you have attorney column, claimant sex column, claimant insurance, seat belt, claimant age and loss. All these columns here. And then you have 1340 observations and 7 rows, 7 columns here. 1340 rows and 7 columns. Now, check if there are any null values in your data set. I'm checking for any null values. So case number column is not having any null values. Attorney column is not having any null values. Claimant sex is having 12 null values. Similarly, claimant insurance, seat belt and claimant age. All these are having our null values. So I can use my describe function and I can get an idea about the basic statistics information for my data set. This is what I can get. Basic statistics information from my data set. Now, I can visualize my data. I can explore my data by creating different types of visualizations. So for example, I can create my box plot using my seaborn library. I'm trying to compare my 2 columns, attorney column and my claimant age column. So I can understand what is the age profile who are going to consult a lawyer and who are not going to consult a lawyer. So 0 means you are going to consult a lawyer. 1 means you are not going to consult a lawyer. So you can understand what is the median age profile of your customers in your data set who are going to consult and not consult your lawyer. Then I'm dropping my first column. I'm dropping my case number column because case number column is not going to help me in my analysis. Is not going to help me in my analysis. So in place is equal to true means I want to drop it from the original data set. And axis is equal to 1 means I want to drop my columns. So whenever you want to drop your columns, you can say axis is equal to 1. Whenever you want to drop your rows, you can say axis is equal to 0. So now your case number column has been dropped. So case number column is dropped. You are left with 6 columns now. So attorney is your target variable or dependent variable and all the others are your independent variables. All the others are my independent variables. Now, I can also create my count plot. So count plot is going to count how many observations you have in your data set. So I have more observations where my claimants are not actually are consulting a lawyer. So 0 stands for observations who are going to consult a lawyer. So in your data set, you have more observations where people are actually consulting a lawyer. You have slightly less observations where people are not consulting your lawyer. That is what you have to understand in your data set. So now I can create a cross-tab function. Cross-tab is nothing but it is similar to a pivot function in Excel. So it is going to do the same purpose for us. Cross-tab, you're trying to compare your two columns, attorney column and claimant insurance column. So these are my attorney column values. These are my claimant insurance values. So attorney value, if I say 0, that means he's going to consult a lawyer. 1 means he's not going to consult a lawyer. And claimant insurance 0 means, go back to our presentation. Whenever you have any doubt, all this will be given in the problem statement first. So claimant insurance 0 means that person is having insurance. 1 means that person is not having insurance. So 0 means that person is not having insurance. 1 means that person is having insurance. So I hope that is what we have. Now what is that we can understand here? We can understand that (585) observations in my data set are not going to have any insurance, but they are consulting a lawyer. That is what you can understand from here. 594 observations are there in your data set who are not having any insurance, but they are also not going to consult a lawyer. That is the information what you can get. So in your data set, you have 585 observations who are not having any insurance, but they are going to consult a lawyer. Same time, you have 594 observations who are not having insurance, but they are also not going to consult a lawyer. What about 76? You have 76 observations in your data set. People who have insurance and who are going to consult a lawyer. So people who have insurance, there are 76 observations and who are going to consult a lawyer first. So you can compare two columns using our cross-tab function. That is what you can understand. Now, I can simply create a bar plot also using the cross-tab function. So most of my observations in my data set are not having insurance and they are also not going to consult my lawyer. 594 observations are there. I can find out from my cross-tab. And similarly, I have around 585 observations in my data set who are going to consult a lawyer. At the same time, they are not having insurance. Not having insurance and consulting lawyer. 585 observations are not having claimant insurance first. Now create a count plot for your seatbelt column. So every column I can explore my data like this. First, I've started off my exploration by understanding what is my attorney column versus my claimant age. Next, I did a cross-tab between my attorney column and claimant insurance. Then I did a bar plot between my attorney column and claimant insurance. Now I'm doing a count plot on my seatbelt. So like this, I'm trying to explore each and every column which is there in my data set. That is what I'm doing. So 0. What does 0 mean in your seatbelt column? So 0 means that person is wearing a seatbelt. So most of your observations in your data set are having claimants who are wearing seat belts for us. 1 means they are not wearing seat belt. So 0 means they are wearing seat belt for us. One means they are not wearing seat belt. That is the understanding what you're supposed to have. Similarly, you can do a count plot on claimant insurance. So most of your observations in your data set, they do not have insurance. They are not having insurance for us. That is what you can understand from your count plot on your claimant insurance column. So I can do a cross tab. I can compare two columns, seatbelt and claimant insurance. So most of my observations in my data set who are wearing seatbelt and who are also not having insurance. They are wearing seatbelt, but they are not having insurance. More number of observations I have belonging to that category in my data set. They are wearing seatbelt, but they are not having insurance. Now, I can do a count plot for my claimant 6 column also. So 0 means male, 1 means female. So what can I say? Most of my observations in my data set are belonging to female category first. They are belonging to gender female compared to male. Then I can do a cross tab between my claimant sex and claimant insurance first. So 1 stands for female. So most of my customers in my data set are females and who are not having any insurance compared to male customers or male claimants. Female observations are more in my data set. Now, I'm going to handle my null values. I know there is presence of null values in my data set, so handle them. So how are you going to handle them? You are going to apply imputation method. What do you mean by imputation method? You are simply going to replace your null values with either mean of that column or median of that column or mode of that column. So for example, if you are working with your categorical data, for example, claimant sex, claimant insurance, seatbelt, they are all our categorical columns. So what is that you are going to do? You have to replace those null values with mode of those columns. So remember this concept. When you are working with your categorical columns, you have to use your mode imputation technique. So what is the mode for your claimant sex column? It is 1. What is the mode for your claimant insurance column? It is 1. What is the mode for your seatbelt column? It is 0. So you are going to replace all your null values with the mode of that particular column. That is what you are going to do. This is called as mode imputation technique when you are working on your categorical columns. What about claimant age column? If you are working on numerical columns, you can either use your mean imputation technique or you can use your median imputation technique. You can either use your mean imputation technique or median imputation technique. So I'm going to use my mean imputation technique, find out what is the mean of your claimant age column, 28.41. So fill all your null values with this value, 28.41. So that is what you are going to do. Fill all your null values in your claimant age column with your 28.41 mean value for that column. You are going to do that. Now, once you have imputed all your columns, you see there are no null values for us. There are no null values in our data set. So that means that we can proceed forward and we can build our model. We can start building our machine learning model, which is logistic regression. So from sklearn.linear_model, import your logistic regression. These are the number of rows. These are the number of columns that you have. Divide your data set into X and Y. So X is all my independent variables. and y is all my target variable. So 0th column is my attorney column, which is having my target variable value, and x is nothing but it is going to have my independent variables. All my 5 independent variables I'm going to have. And initialize your logistic regression model. Initialize it. And fit it on your x and y data. So fit it on your x and y data. Now after fitting, you can simply find out your coefficient values. You can simply say classifier dot coefficient. It is going to tell you what are the coefficient values or parameter values for all your independent variables. Your beta 1, beta 2, beta 3, beta 4 and beta 5. All these are your coefficient values for your independent variables. Then I can use one ready-made attribute in my logistic regression function. It is called as predict underscore proba. So this is going to give me my probability values. So probability value for 0, probability value for 1. So for the 0th observation, you are predicting there is a 99% chance of the person consulting a lawyer, and there is less than 1% chance that the person is not going to consult a lawyer. So that is how you are making your predictions for all your observations. These are the probability values. These are the probability values. So that is what you are doing. Now, simply say your classifier model dot predict on your x. You are going to predict your values. So these are my predicted values. So for the 0th observation, my final prediction from my logistic regression model is 0. What does this mean? That this observation is actually going to consult a lawyer. This observation is actually going to consult a lawyer first. So that is how you are going to make all your predictions. Now, so now you are trying to simply concatenate our two columns, and you're trying to compare what is the prediction value and what are the probability values. So for 0th observation, there is a 99% chance that my claimant is going to consult a lawyer, and there is less than 1% chance that claimant is not going to consult a lawyer. So similarly, in the first observation, there is a 50% chance that the person is actually going to not consult a lawyer, and there is 49% chance that the person is going to consult a lawyer. So threshold value by default is 50% for us. So if your probability value is greater than 50%, it is going to assume 1. If it is less than 50%, it is going to assume 0. So that is the default threshold value, what your SQL and logistic function is going to do. And it is going to make your predictions. All these are the predictions. Now, confusion matrix. From ExcelR.metrics, import your confusion underscore matrix. Apply it on your actual values and predicted values. So you are getting your confusion matrix. Now you can also apply the crosstab function and you can get your confusion matrix. This is my confusion matrix. These are my actual values. These are my predicted values. And then you have your true negative, your true positive rate. And what is that you can understand? Actual value is 0, but your prediction is 1. That means your false positive first, false negative first. So your prediction is 1, but actual value is 0. So 1 is our positive class, 0 is our negative class. That is what we have understood. Now, find out what is the accuracy. What is the accuracy for us? 435 plus 508 divided by 1340 observations. That is the accuracy. Accuracy is 70% for your 70% for our model. Now, find out what is your precision recall F1 square using your classification underscore report. So your model is having a recall score of 78. So it is slightly better in estimating the value of 1 compared to 0. It is having a higher accuracy when it comes to predicting your positive class compared to your negative class. What is the overall accuracy for your model? It is 70% for us. This is the overall accuracy for our model. Totally, you have 1340 observations. 1340 observations you have. So no need of any manual calculations. Everything is being computed from your confusion matrix. True negative, true positive, false negative value you have. Simply apply all your formulas, sensitivity. Okay. TP by TP plus Fn. TP by TP plus Fn. So 508 by 508 plus 147. When you solve for this, you are going to get your precision value. You are going to get close to 78%. So do that manually and you are going to get that. Now, ROC curve. From ExcelR.metrics, import your ROC underscore AUC underscore score. This is the function which is going to help you find out the area under the curve for your logistic regression model. So apply this on your actual values and on your predicted values. What is the area under the curve? 70%. This is the accuracy for your model. Now, how can you plot it? Simply apply your ROC underscore curve, your actual values, your predicted values. You have them, predicted probability values for your positive class. And then plot your false positive rate values, true positive rate values. This is your ROC curve. This is our ROC curve for our logistic regression model. So my x-axis label is false positive rate. My y-axis label is true positive rate. And my title is receiver operating characteristic. And legend has to be lower right. So that is how I'm actually making my ROC curve. So this is what you're supposed to do. This is the program for your logistic regression. That is the concept. So all of you try to practice when you are at home. Try to practice the concept of logistic regression. It is important for us. You have to understand concept of confusion matrix. You have to understand specificity, sensitivity, F1 score, all these things you have to understand. And then try to understand the concept of ROC. So that is the idea about your logistic regression concept. So I hope all of you are able to follow. The first time when you hear this concept, it will be slightly confusing for us. But slowly when you get back to our recording, our session, our codes, our presentation, then everything will automatically fall into place for us. Okay. So with that, thank you very much for your time today. Take care, all of you. Stay safe. And I'm going to see you all again tomorrow with another topic. And we are going to practice it in Python. So take care.